Well, it's day 30 on the Oregon Trail. We're kind of getting sick of each other. We're looking forward to seeing some new people. We're going to Excretory City to see Jordan Flynn. He's the mayor there. We're hoping to get some new supplies and fresh food. Oh no. It is a ghost town.
Nothing in Excretory City.
What happened to Jordan Flynn? Why is he not here? I do not know.
Why is this book blank?
Why is there no information on his sheet in the book?
Let's take a look at this.
Jordan Flynn has gone missing. As you can see, it's starting to rain out, so we're going to head into the covered wagon. Ouch, that hurt. Oh.
Now that we're safely inside the covered wagon, we're going to talk about the muscular system. We have three types of muscles: skeletal muscles, cardiac muscles, and smooth muscles. Skeletal muscles are the muscles that are voluntary and striated. They are found throughout the body and control movement. The muscles are named by their location, shape, and size. Cardiac muscles are muscles that are found in the heart, and they are striated and involuntary. These cells are responsible for contraction of the muscle, sending blood to the atria and ventricles. Smooth muscles are muscles that are found in the walls of hollow organs, and they are non-striated, and they are also involuntary. They control contractions in the stomach and intestines. The muscle structure, the endomysium is a fine sheath of connective tissue composed of reticular fibers that surround each muscle fiber. The perimysium surrounds groups of muscle fibers called fascicles. The epimysium is a dense overcoat that surrounds the entire muscle. Now, muscle contractions. There are myofilaments that are composed of thick and thin fibers. Thin fibers are chiefly composed of actin, and thick fibers are composed of myosin. Thick filaments extend the entire length of the A band, and a thin filament extends across the I band and partly into the A band. In this sliding filament model of contraction, thin filaments slide past the thick filaments, so the actin and myosin filaments overlap to a greater degree. And then during repolarization, it begins immediately after depolarization, and waves of the sarcolemma permeate change because the Na canals close and the potassium canals open. And repolarization occurs in the same direction as depolarization, and they must occur before the muscle can stimulate again, and the ionic concentration of the resting state is restored by the NAK pumps. And since muscles can only pull for every movement, there is a flexor and an extensor. When you flex your bicep by curling your arm, the bicep is the flexor and the tricep is the extensor. And that's the muscle system.
We're getting wet in the covered wagon, so we're going to head into the garage. Now we've moved on to Circulation City. This is a picture of the human circulatory system. And the human circulatory system functions as a transport for nutrients, wastes, oxygen, CO2, and hormones to spread throughout the body. Flow of blood is very important in the body, and the circulatory system has a major part in that. Blood flow from the right atrium to the aorta to spread it throughout the body. Deoxygenated blood from the body enters the right atrium. It flows through the tricuspid valve into the right ventricle. Really? You can keep going?
Yeah.
Alright, keep going. Into the right ventricle. Contraction of the ventricle then closes the tricuspid valve and forces open the pulmonary valve. Blood flows into the pulmonary artery. This branches immediately, carrying blood to the right and left lungs. Here the blood gives up carbon dioxide and takes on a fresh supply of oxygen. The capillary beds of the lungs are drained by venules that are the tributaries for the pulmonary veins. 4 pulmonary veins, 2 draining into each lung, carry oxygenated blood to the left atrium of the heart. From the left atrium, blood flows through the mitral valve into the left ventricle. Contraction of the ventricle closes the mitral valve and opens the aortic valve at the entrance of the aorta. So basically it's just telling you how blood flows into the right side and it's deoxygenated, flows through the lungs, gets oxygen, and flows out the left side and carries oxygen to the body. It's day 45 here on the Oregon Trail. We're going to see Joey in Nervous City. Joey!
Joey?
Joey!
Joey.
Must be a ghost town.
Oh, great. Joey's not here either. Odd. Well,
Yeah.
Alright, day 100 and we made it to Oregon. Long journey. Here's the respiratory system. Okay. Smoking can have detrimental effects based on large amount of carcinogens, which are in cigarette smoke and other factors. Tar inhibits the process of gas exchange, making it hard to breathe. Also, nicotine constricts blood vessels, which doesn't help. Nicotine also freezes up the cilia, which moves the mucus out of you. And when they don't work, you have a lot of tar and you can't get rid of it.
Okay, breathing is mostly done by the diaphragm. The diaphragm is a large muscle that separates the thoracic cavity from the abdominal cavity. During inspiration, the diaphragm contracts, creating a vacuum in the thoracic cavity. This vacuum inflates the lungs by drawing air into the body through the trachea. During expiration, the diaphragm relaxes, allowing the lungs to deflate.